This conference will now be recorded.
In yesterday's session, we were discussing about RDS. So how to create RDS in a secure way in a private subnets, and how to connect to that RDS via some applications like Java-based applications, and we deployed some application, and also we access those applications, those APIs via load balancer also. Are you guys able to create at least RDS maybe in a public subnets, and are you guys able to practice at least like connecting to the RDS instances? Is everyone clear what is RDS, how it works? Before I go for the next set of services in AWS, which we wanted to. In today's session, we'll try to understand one more service, that is DynamoDB. So what is this DynamoDB? So how to create this DynamoDB, and again how it works, we'll try to understand. So DynamoDB is a managed key value database. It's a key value database, right? So we classified as a NoSQL database. So you can't delete parameter group and that option group, because that is, you have not created a parameter group. That is default parameter group created by AWS only. So AWS is only managing that parameter groups, right? That is just a configurations for which you want to use by your RDS. That is parameter groups managed by AWS. So you can't delete that parameter groups. Those are default parameter groups managed by AWS. You can't delete that, leave that, because those parameter groups are not owned by you. That is owned by AWS accounts. Okay, so leave about it and try to focus on this one today. So we'll try to understand what is this DynamoDB. So DynamoDB is a managed NoSQL service. It's a managed NoSQL database. We already discussed SQL databases and NoSQL databases, right? So SQL, RDBMS, where the data will be maintained in a tabular format with columns, right? There will be a primary key, foreign key, relationships like that. It's a managed databases, so basically that relational databases. But we have NoSQL databases, right? Like document-oriented databases. We have some softwares, right? Like MongoDB, MySQL. There are many well-known NoSQL databases available, like MongoDB, Cassandra, Couchbase. These are the softwares we can use to set up the NoSQL databases. But when it comes to DynamoDB, so it's a managed NoSQL database service. It's a managed NoSQL database as a service. So you can understand what we mean by managed. So who is going to manage the computing, storage, configurations, that installation and everything for running that NoSQL database? Basically, it's a managed, right? So AWS will take care. The background, that computing, storage, all those whatever is required for provisioning and using that NoSQL databases. So DynamoDB is a managed NoSQL database service that will give strong consistency and performance, and that will abstract the complexity from the manual setup. You no need to manually set up and manage the NoSQL database. If you go with the DynamoDB, everything will be taken care by AWS only. So Amazon DynamoDB gives very good performance. It will deliver a single digit millisecond performance at any scale, at whatever load you have, the database, the NoSQL database load, right? It will give very good performance. It's a fully managed durable database with the built-in security, backup and restore, right? And it can handle more than 10 trillion requests per second also. That my DynamoDB can handle more than 10 trillion requests per second, can support peaks more than 20 million requests also. You will get very good performance when it comes to NoSQL database if you go with the DynamoDB. It's a managed NoSQL service offered by AWS. So with the managed service, users can only users like AWS users like developers, DevOps guys, basically the applications. The applications can interact with any application, running application. You no need to worry about thinking like server health, storage, network connectivity. So with Amazon DynamoDB, AWS provisions and runs the infrastructure for you. AWS will provision and run the infrastructure for you, and the DynamoDB can be used for managing NoSQL data, NoSQL data, and automatic data replication will happen in the DynamoDB across multiple zones in that region, and also the data will be backed up to S3. We can integrate DynamoDB. We can use DynamoDB with other services like Lambda, and also you can deploy your applications in EC2 and you can interact with the DynamoDB, or you can deploy your applications in EKS cluster also, and you can interact with the DynamoDB for retrieving and storing the NoSQL, the document-oriented data, or you can integrate with Lambda also. You can integrate this DynamoDB with the various other services. And pay as you go model here again. So based on how much data you are storing and how much you are retrieving, only based on that DynamoDB will charge. You are not going to pay for the hardware here with the DynamoDB. You are going to pay for how much read operations you are doing, how many write operations you are doing into the DynamoDB. Based on that, they will charge. And the security and access control can be applied using AWS IAM. Again, DynamoDB, you can grant permissions to the DynamoDB for inserting and accessing the data using IAM policies. So in the DynamoDB, you can create a table. In the DynamoDB, you can create a table. So DynamoDB is a key value database. DynamoDB is a key value database that organizes the data in the tables, and each table contains collection of items. With some primary key, you are going to maintain some data, but the data is not in a column format. It is a table only, but not in a column format. It is in a document format, JSON format. But each DynamoDB item will have a primary key to uniquely get the document. So each item is a collection of attributes in the DynamoDB table. So in the DynamoDB, you can maintain like scalar attributes like strings, numbers, integers, and nested attributes also, right? And whenever you are creating a DynamoDB, right, you need to provide your partition key. When you are creating a DynamoDB table, right, you need to understand some concepts. This is something related to database, okay? So when we are trying to create a table in the DynamoDB, right, you need to define a primary key. It is going to be maintained in a table format, but not columns. So there will be only one column, that is a partition key. We call it as a primary key. But everything in the document format, JSON format. It is not like a table format. Table without columns. It's a DynamoDB is a key value pair. It will have only partition key, that is kind of a primary key, and rest of everything is in a JSON format, document format. It is going to maintain. So DynamoDB, there are different types of primary keys, right? You can use with a DynamoDB, that partition key. That partition key is like a unique key, the key used to identify the partition on which the data is stored. And a sort key, this key identifies the location of the item in a particular partition, on which location in the data is stored, right? So this partition key and sort key will be used by DynamoDB to uniquely identify where exactly the data is stored in the DynamoDB service. And with these two keys, with the partition key and sort key, you can create a simple primary key. A primary key is like a unique key that you can identify the document, the data in the DynamoDB table. Otherwise, with multiple combinations, you can create a composite primary key. Composite primary key is like combination of two attributes. Like employee ID and organization ID. Combination of two IDs, we call it as a composite primary key. Simple primary key is like just like an employee ID, like that, single column, single attribute. So when we are creating a DynamoDB table, you need to define partition key in the form of that primary key. And also, if required, you can define the composite primary key with the combination of two attributes. So again, the DynamoDB, when you are creating a DynamoDB, right? The performance is based on the what mode you created a DynamoDB table. The performance is depends on in which mode you have created a DynamoDB table. So the DynamoDB table can be created in a provision mode, created in a provision mode or on-demand mode. The DynamoDB table, when you are creating a DynamoDB table, so the performance of the read and write into the DynamoDB table, the read and write capacity is based on these modes, provision mode and on-demand mode. So when we are creating in a provision mode, you need to specify the number of reads and number of writes per second required by your application. So how many read operations you are expecting and how many write operations you are expecting by the DynamoDB as per your application requirement, you need to specify. In a provision mode, you need to specify the number of reads and writes per second required by your application, which is connecting to the DynamoDB, and pay based on the whatever capacity you have provisioned. And this usage is billed hourly, regardless of how much of that capacity was consumed. They are going to charge based on the hour if you create a DynamoDB table in a provision mode. And if the limit of the provision mode is exceeded, right? Suppose you defined, right, maybe per second I am going to do 100 read operations. Just imagine, let's say per second you are going to perform 1000 read operations, 1000 write operations. You defined in a provision mode, but your application is trying to read more than 1000 per second. It is trying to read more than 1000 requests per second. So if the capacity is exceeded, this will lead to the request throttling. Request throttling in the sense the DynamoDB will not, write the data if your requests are throttling. You are exceeding that whatever capacity you created. If it is exceeding, a request throttling will happen in the DynamoDB. So the application which is connecting to the DynamoDB won't be able to read or write the data during this period. Suppose you defined in a provision mode number of read and number of write operations which you are going to do in the DynamoDB per second you defined, and you are trying to do more than that whatever provision, right? A request throttling will happen in the DynamoDB. So applications will not be able to read or write the data during those periods, right? And a provision mode is good for applications that have a predictable consistent traffic. Predictable, you are predicting that there might be a 10,000 requests will go to the DynamoDB per second for reading the data. If there is a 10,000 requests will go to the DynamoDB for writing the data, you are predicting, then the provision mode is good. But if you are not predicting, you are not able to predict, right, how many read operations may happen in the DynamoDB table, how many write operations may happen in the DynamoDB table per second. If you are not able to predict, then they are offering one more on-demand mode. So DynamoDB on-demand mode has a flexible billing option which is capable of thousands of requests per second without any capacity planning. You no need to plan anything, so it can handle how many requests comes, right? And on-demand mode offers pay per request pricing. Pay per request. Here billed by hour. Here provision mode billed by hour, but here based on how many requests are coming for DynamoDB table for reading the data and writing the data, based on that they are going to charge. But on-demand mode accommodates the customer's workload instantly. Even though there is a huge request coming to the DynamoDB table for reading and writing the data, on-demand mode can handle. But if you are able to predict, you can define how many read operations, write operations you need per second for that applications in a provision mode, and you can go with provision mode. But you are not able to predict, right? You can go for a on-demand mode. So is everyone clear? When you are creating a DynamoDB table, you have two options. The performance of the database, the DynamoDB database table, is based on the mode which you created, on-demand mode or provision mode. Is everyone clear? What is DynamoDB table? First of all, what do you mean by this provision mode, on-demand mode when it comes to DynamoDB table? Is everyone clear, guys? Any confusion, any doubts here? And this DynamoDB, what do you mean by this DynamoDB? And what do you mean by this provision mode, on-demand mode? Is everyone clear? Before I create one DynamoDB table, and I will show how to connect to the DynamoDB table via applications again, Java-based applications I will use. So DynamoDB table, you need to create a table so that your applications can use the DynamoDB table as a NoSQL database table to read and write the data. Okay. So let me go to services. Here again, that comes under database only, but instead of RDS, right? Instead of RDS, there is one more service called DynamoDB. So RDS, managed relational database as a service, RDBMS, SQL databases like MySQL, Oracle, Postgres, like that. But this DynamoDB managed NoSQL database, NoSQL database. So let me go to this DynamoDB. Now, Amazon DynamoDB, a fast and flexible NoSQL database service for any scale in the sense at whatever load you have, let it be any, how many requests is coming to this DynamoDB, it can handle, right? And the DynamoDB table, you need to create a table first. So DynamoDB charges for reading and writing and storing the data in your DynamoDB tables, right? They are going to charge based on how many read operations you are doing on the DynamoDB table, based on write operations you are doing on the DynamoDB table, like that. So let me create a new table. This new table, I will create one table in the this service. Then I will use the RDS. I will use one applications to connect to this DynamoDB table for reading and writing the data. So let me take one application. I have one application. I have again one application that is developed again in Java only. That is developed again in Java only. That is developed in Java only. So this is one application. Let me open this application in a Visual Studio Code so that you can understand. So let me explain that application. Let me explain that application first. So this is one Java-based application. Developer is developer developed one Java-based application. They are using DynamoDB to store the data. There is one API. There is one API. There is one API. That API is taking some input, like user's input, like some data, maybe the username, like the first name, last name, email, and age, some user information. The user information it is trying to expect. The API is expecting some details like you first name, last name, email, and what is he says, like that. This is one API. This API is internally contacting DynamoDB, and it is maintaining the data. It is maintaining the data in the DynamoDB table. It is going to maintain the data in the DynamoDB table. So I will create one DynamoDB table and I will pass on those details to my application. I will pass on those details to my application. Sorry, not this one, not this application. Let me open. Yeah, this one only. Sorry. AWS DynamoDB. Let me open this application. I opened wrong application. Let me open this application. I opened wrong application. So there is one application, Java based application. It has some API. This has some API. This has some API. So this API is taking some input. This API is taking some input. Some information like employee name, first name, last name, like that. Employee name, first name, last name, phone number, email, department, salary, like that. It is expecting some input. So this data I'm going to maintain in a NoSQL database, document-oriented database. So that's why I use DynamoDB related libraries. So there is a DynamoDB related libraries used in this Java based application. So there is a DynamoDB SDK, Java SDK is available for DynamoDB. The developer has used this Java SDKs to work with the DynamoDB. Using that SDK, he is trying to connect to the DynamoDB. He is trying to connect to the DynamoDB. I need to provide the DynamoDB endpoint also in the code. DynamoDB URL, basically DynamoDB endpoint. It is kind of a one HTTPS endpoint, DynamoDB endpoint, and in which region you have the DynamoDB table, and basically it requires kind of a access keys and secret keys. So the applications who want to talk to the DynamoDB need some kind of a access key and secret key. So it is one service, kind of a web service only. This is that web service URL, and it requires some access keys and secret keys to contact the DynamoDB. So we are providing AWS access key, secret key as an environment variable, and we are given that DynamoDB endpoint like this we will give. And the code whatever has been developed by this developer, there is a API. There is a API which is taking the data, REST API. This API is internally contacting some other Java class. This API is internally contacting some other Java class, and it is trying to internally contact one more class, and using DynamoDB APIs, using DynamoDB SDK, it is trying to connect to the DynamoDB and create documents in the DynamoDB. So instead of you set up the database, NoSQL database, you are using DynamoDB database. So let me create a table. First, I need to create a table, DynamoDB table. So I don't have any table. Let me create a DynamoDB table. I'm giving table name. I'm giving table name as employee. This is the table name. The code is looking. I'm creating a table called employee. And the partition key is important. So some kind of a unique key. I'm using ID, kind of a employee ID. So this is my partition key as per my code, right? This is the partition key I want to use, that ID. This is I want to use this ID, kind of a unique ID. And again, it is an auto-generated key. So I am saying that Java SDK to generate some unique ID for each and every employee. So the Java code will take care of generating the unique ID, and this is kind of a my partition key, kind of a primary key. What type of that one? Basically, I am saying string, kind of a string type, not number. So with this, I am creating a DynamoDB table. Here you have these options, right? What is the mode? The table, in which mode you want to take. So if you go with provision mode, you have that read capacity, write capacity, like that. But if you want to go customize that, right? Whether you want to go with DynamoDB standard IA, again, whether you want to go in a provision mode, whether you want to go in on-demand mode. If I go with on-demand mode, right, it is going to handle any request, whatever it is coming. If I go with provision mode, I can specify the units, like maximum units, read units, write units, all those things like that. So based on your requirement, you can go with provision mode, or you can go with on-demand mode. You can create a DynamoDB table with the default settings also you can create, or you can customize your settings. So let me create with the default settings only. I'm creating a DynamoDB table. Now this table as of now don't have any data. This DynamoDB table don't have any data. Let me show that this table. If I click on this table, it will show if there are any items. Items are like a number of records. As of now, is that a table, DynamoDB table has any items, in the sense any data, any records basically? No. And if you see, if you want to query also, you can query. If you want to query, you can explore table items like this. If you go to explore option also, you can see is there any data. Explore table items also option is there. So if you see, there is no data also. There is no data. There is no data as of now. If you click on that explore, right? If you see, you can run some kind of a NoSQL query. There are no data. There is no data also here in the DynamoDB table. Now let me use DynamoDB endpoint, DynamoDB query endpoint to connect to the DynamoDB. Guys, the endpoint, there is a AWS documentation has given. These endpoints are standard based on the region your DynamoDB table is created. There is an endpoint. These endpoints are not going to be changed. These are provided by AWS only. My DynamoDB table is created in a Mumbai region. So the DynamoDB endpoint, the endpoint to connect to the DynamoDB is this one. DynamoDB, your region name dot amazon.aws.com. This is my DynamoDB endpoint to connect to the DynamoDB by your application. So let me update that in my application code, because application should know where is the DynamoDB. So I am saying this is the DynamoDB endpoint, something like this. HTTPS you need to give. This is the DynamoDB endpoint. But here you need to provide access key and secret key, because DynamoDB will be connected via access keys and secret keys by the clients. I hope you know already access keys and secret keys. At least if you have attended AWS sessions with me, whatever we already discussed in DevOps course, you know what is IAM, what is access key and secret key. So you need to use those access keys. That access keys I can hard code here in that YML also. For now, let me use root access key only. For now, let me use root access key only. For now, I am using root access key and secret key only. But in real time, you have a normal users, IAM users. You can attach DynamoDB policies to your user, and you can use that user access keys and secret keys in your applications also if required. So for now, let me use root user access key and secret key only. For now, let me use root user access key and secret key only for connecting to that application. So you can generate access keys and secret keys. Only two access keys and secret keys can be generated for your user. So I already have two. Let me delete one of the access key and let me generate new access key. That access key and secret key you can generate here in the security credentials. So let me deactivate this access key and let me generate a new access key and secret key. Let me generate the new key, new access key and secret key. As a root user only I am generating. So let me take this access key. This is the access key. This is the secret key. Now this I will provide in the code. Guys, there is some best practices in the code also, but this is nothing to do with the AWS or Terraform. Is it recommended to hard code something like this in the is code, and is it recommended to check in this confidential kind of data into the SCM? This is security risk, your security breach here. Because if you check in your access keys and secret keys like in the SCM, right? So whoever has access to that SCM tools, will they able to see these access keys and secret keys? Is there a possibility of misusing these access keys and secret keys to manage other AWS resources also? Yes. So this is not a best practice. Whether you use any confidential data in a code, it should not be used here. So what I can do here, right? Since it's a Java code, instead of hard coding like this, I can refer it as an environment variable. But can I pass these environment variables when I am running my application? Whether you are doing a virtualized deployment, whether you are doing a containerized deployment, that doesn't matter. Can I set these environment variables in the system where I'm going to run this application? Or can I set these environment variables to the container if I'm going to run this application inside a container also at runtime instead of hard coding here in the code? Yes. So I'm not going to hard code. If I hard code also, it will work. If I hard code also, it will work. Nothing will be a problem when it comes to a RDS standpoint. But the best practices in the coding, you should not maintain this type of data in the SCM repositories. You are going to check in this one as a developer. They'll check in this one into the SCM, and it is not recommended. So the Java also has some concepts of environment variables. I can pass these environment variables before I run this application. You know, right? Export. Can you use export? Or if you guys are using run -d at runtime, also you can pass those environment variables. Whatever way you want to set environment variables, you can set. So I just keep a note of this access keys and secret keys. I will set this in the environment variables. Otherwise, you hard code since you are learning only, right? You are not a developer. So hard code like this also. Hard code like this also in the code. But instead of doing like this, I can do before running that application. I can refer it as an environment variable. I can say export whatever environment variable name I was using under this value like that also. For now, let's hard code also fine because you are not a developer, right? So let's leave this hard coding only. Now let me build this application. Let me build this application. We are just giving DynamoDB URL and the access key and secret key, but that access key and secret key, that user should have access to the DynamoDB table. Since we use root user access key and secret key, do we have all the permissions? Not only for DynamoDB, for everything it will have, right? You already know some concept, right? So since I am using root user access keys and secret key, by default they have a admin rights to all the services. So DynamoDB table access also will be there for that user, root user access key, secret key. So let me build this application. Let me go to command prompt. This is again one API. This is again one API. Let me build this application. I am running locally in my local laptop, and my local laptop can contact this DynamoDB guys because it is one HTTP endpoint, HTTP URL. From my local laptop also I can contact this DynamoDB URL. So let's compile this application. Let's build the jar file. Then I'll run the jar file to deploy this application. So I got a jar file. I got a jar file. In the target folder, I have a jar file. This jar file. Let me run this jar file. I have hard coded everything in the code only. So I have hard coded this access key and secret key in the code. So I no need to pass any environment variable like that. Let me run java-jar, that DynamoDB jar file I am running. Now it is one web application again, REST application, REST API. So it will contact the DynamoDB. If I can get the data from DynamoDB table, if required, I can insert the data, update the data via this application, via this API. So application is started locally in my local laptop. Application is started locally in my local laptop. So the application is running on this port 8081. So let me use some kind of a REST client because it's a REST API, not a GUI application. It's a REST API. There is no GUI in that code. So let me open some REST client kind of a Postman. to get the data and insert the data or update the data, but that application is internally storing the data in the DynamoDB. Let's wait for some time. So let me see if there is any data. So I deployed that application locally. I can say localhost, because I deployed my application locally under the 8081 and the API context. Let me open that application API. What is the API context? I want to know. So the API is employee, context is employee. So let's see if there is any data. First of all, because we don't have any data in the DynamoDB, internally that application is contacting DynamoDB. As of now, do you have any records, employee records in the DynamoDB table, that NoSQL table? If you see, as of now, you can see here also, it is giving 200 response. That API is internally contacting DynamoDB, and there is no data also. You can see here also in the console. You go to DynamoDB table. You go to DynamoDB table. You go to DynamoDB table, and there is no data because no one has inserted as of now. No records has been created. It is empty. It is empty. So there are tables, right? There are tables, but make sure you switch to whatever region you created a table. So I went to IIM, that's why it was switched to global. Let me switch back to Mumbai. In the Mumbai region, I have the DynamoDB table, but there is no data in the table, right? You can see still there is no records. Still there is no records because we have not created, inserted any data. So you can see explore table items. If you see, there is no data. There is no data. Now there is a post call also. There is a API. There is a API. This code, we developed some code, right? The Java application. Developers will write the code. The Java application, there is a post call also, where I can pass employee information. I can pass employee information. So employee information like first name, last name, REST API. REST API. So first name, last name, number, email, department, salary, but ID will be auto generated. I no need to pass, right? So let me create a one more request like post call. It's a post call, and this is the URL and body. Let me pass the body. This is API. Developers developed this APIs. Developer developed this APIs. So that API is expecting some request in the form of JSON. So let me create a data. First name like this, last name, first name, whatever records you want to insert. So in the form of JSON, I am creating a data. First name. This is your API call. Last name, and whatever the data it is expected by that API. So if you don't know also in the real time, the developers, you can work with the developers. So what is your number, phone number, kind of a number. Let me say something like this. Salary, something, whatever you want to mention, you can mention. Age, whatever you want to mention. And some information I am capturing. Basically, this I call it as a payload, request payload. And I am making a API call. So this API will internally contact the DynamoDB table. That is where it is persisting the data. It's a NoSQL database. So let me click on send. Now I got a message 200 successfully, and it has written the again same data back also, but email I have given, there is some typo. Okay, that's why it is written null. Okay, let it be fine. If you see now in the DynamoDB, do have some record like that record maintained here in the DynamoDB table, that application created a data in the DynamoDB table. This is where it is maintaining the data. This is where it is maintaining the data. So if I want to update this, there is a API again. There is a API. Let me duplicate this tab. The developer has developed the APIs. You know, right? Application, GUI, API, data layers. So developer has developed one API to update the data. Also, there is a put method. There is a put method. It is going to expect. It is going to expect again data, and it is expecting with ID also. This ID is created. This is something to do with code. Okay. So let me update the data. I mean to say I am trying to update the record. I am trying to update the record for that guy. Because the last time email came as null or empty. Let me set some email. And department, let me set. I am making one more API call to update the data. So application is contacting database, and data in the database data is getting updated. Now you can see this updated data. Now if required, I can create a one more record, new record. Let's say let me create a one more record, new record. Let me create a one more record, that is post call. Let me make a post call. Let me make one more request to create a new record. Some new data. So this data again, one more post call. I can see one more record got created here. So it's a NoSQL database. We can use in the AWS. Applications can connect to the database. If required, you can create a records, update the records. Let's say there is a delete API also. There is a delete API. There is a delete API. So you can delete some record, whatever record you want to delete. You are requesting API. You are making a request to the API. There is a API. There is a API. There is a code here. There is a code here, right? Delete by ID. So you are passing that ID, whatever is created by here, right? Auto-generated ID. You are taking this ID, kind of a partition key, that ID. So you are making a API call like this. You are making a API call like this. With a delete call, there is a API. These records get deleted from the database. But now you are managing the application. But who is managing the database? That NoSQL database, kind of a key value database for us. Are we worried about scalability, availability, performance of the database? Now that the NoSQL database? No. So the database is managed by whom? The database. The NoSQL database, you can see there is only one record. If required, I can delete this record also via that API only. I can delete this record also via that API only. In real time, these APIs can be internally invoked from GUI. GUI. Now this record is again deleted. The NoSQL database don't have any data now. So now we can focus on the applications, but we can leave everything the database standpoint, NoSQL database. Who is managing the database? The performance, scalability, storage, AWS. So this DynamoDB table, this DynamoDB is a NoSQL database. DynamoDB is a NoSQL database. So is everyone clear what is DynamoDB? how it works basically? It's very simple service, but very important service also. Very simple service, at the same time very important service also. If you need any NoSQL database, instead of you set up on your own, instead of you create some EC2 instance and run kind of a Mongo database software, or instead of you set up and install Cassandra software, or instead of you create some server and set up Couchbase or Mongo, you let AWS to take care in the background. So you can go with DynamoDB. It will give highly available NoSQL database as a service. Clear? What is DynamoDB? How it works? Now, DynamoDB, if you guys observe, when you created a table directly, but did we selected kind of any VPC, any subnets like that here? No. It's a managed serverless service. It's a serverless service. You are not creating any, you are not selecting any VPC, any subnet like this. But how can I make this DynamoDB secure? How can I make this DynamoDB secure? There is some practices, best practices you need to follow to make DynamoDB secure. So you need to enable encryption in REST. You need to enable encryption at REST. By default, DynamoDB enables encryption REST for all the tables. So by default, it does. There is no option to override this setting. So all the tables are inherently encrypted using AWS keys, right? So already there is an encryption at rest. So whatever disk internally this DynamoDB service is using, the data will be encrypted at rest. So there is already one security feature. And also, how do you authenticate DynamoDB basically, right? Using IAM. So who can read, who can write the data to the DynamoDB table? Can I grant that access to the DynamoDB APIs via IAM? Yes. I also used IAM only, right? Did I use IAM access keys and secret keys to insert and read the data by that application via APIs only internally? Yes. So authenticating the DynamoDB access using IAM you will do. And you can use policies also. You can use IAM policies, IAM roles, or IAM concepts for authenticating. And if you don't want to make the DynamoDB endpoint publicly available, if you don't want the DynamoDB publicly available, the DynamoDB endpoint, by default DynamoDB sends the data via internet. By default DynamoDB sends the data via internet. This DynamoDB endpoint, right? Whatever DynamoDB URL we used, this is directly works in the internet. So if you don't want, right? If you want to prevent your sensitive information from reaching untrusted network, you can use VPC endpoint. In the VPC, there is one more concept. You can create a VPC endpoint, and using VPC endpoint, you can reach a DynamoDB table in a private channel. So if you don't want the DynamoDB public endpoint, you create a VPC endpoint, and you can enable the VPC endpoints for your DynamoDB table. And you already encryption is there. So encryption at rest, encryption at rest, encryption at rest, by default already it is there. So if you want to make DynamoDB secure, already encryption at rest is there. You can manage access to the DynamoDB for reading and write the data using IAM policies. And if required, you don't want the DynamoDB endpoint to be used in the public internet, you can create a VPC endpoint, and you can access the DynamoDB via VPC endpoints, kind of a private network. Is everyone clear? What is DynamoDB table? Basically, what is DynamoDB? It's a service, NoSQL service. Using DynamoDB, you can create a table and you can read and write the data to the table, NoSQL database. It is very simple service, but important service. So If required, you can deploy this application and start exploring. Otherwise, just create a table and you just explore like what is DynamoDB, how to create a table, right? Like this, I can create some table, whatever partition key I want to give, and I can create a table like this. But there should be a code, there should be some kind of a APIs or code, so that the applications or APIs can interact with this DynamoDB service to read and store and update the data in the Dynamo tables. Once your practice is done, if required, you can delete these DynamoDB tables also. Whatever table you have created, if required, you can delete these DynamoDB tables also. It's very simple service, guys. Any question, any queries before I conclude the DynamoDB service? Why I am discussing this DynamoDB table, right? When we use Terraform, in Terraform we are going to maintain state. By default, it is going to maintain local state. By default, the Terraform will maintain the state file locally. But that is not going to work. I told that is not going to work when multiple people are working on the Terraform scripts, right? So you need to maintain the Terraform scripts centrally. We can use S3 backend. You can use S3 backend to maintain the Terraform state. At the same time, in the Terraform, we are going to use DynamoDB table also to maintain the lock for that state file. So again, multiple, at a time, multiple people cannot work on the Terraform, Terraform updates, right? So that time, this Terraform can use DynamoDB to maintain the lock file. So if someone is working on the Terraform, basically if someone is executing the Terraform apply, unless until that is completed, no other guy should again update the same. So Terraform can internally use S3 to maintain the state file, and Terraform will internally use DynamoDB. We need to create a DynamoDB table for Terraform to maintain the lock. So that's why we discussed DynamoDB also. So is everyone clear DynamoDB? DynamoDB is a NoSQL database. Your applications also can use DynamoDB for maintaining some kind of a key value data. And Terraform remote backend will use DynamoDB to maintain the lock, that state file lock. That's why I discussed DynamoDB. So that's it for today, guys. That's it for today. I'll continue tomorrow with another AWS service, EKS. So EKS, I am not going to explain Kubernetes, okay? I'm not going to explain what is Kubernetes, what is its architecture. I will just show you how to create a EKS from AWS console. I hope you guys already know what is Kubernetes, what is self-managed Kubernetes cluster, what is managed Kubernetes cluster. You should have a background of Kubernetes. I'll just create a EKS tomorrow, and once this EKS is done, I will explain something called CloudWatch and IAM and CLI. So in next three sessions, that is tomorrow EKS, Friday CloudWatch, Saturday IAM and CLI. With this, the first half of the AWS Terraform course will be done. The second half, the actual Terraform, I will be starting from Monday. Monday we will start the Terraform. So all these things, like what is cloud, introduction to the cloud, what is cloud service, we discussed about some cloud services, so that you can easily understand Terraform. Terraform I will be starting from Monday. So tomorrow EKS, day after tomorrow CloudWatch, Saturday IAM and CLI. From Monday I'll start the actual Terraform. Clear, everyone? Thank you. I'll continue tomorrow. Tomorrow we'll discuss EKS. We'll see you tomorrow. Guys, ECR, EKS, that is nothing to do with Terraform. You should have a DevOps background. You should have a Kubernetes background. So try to explore ECR yourself, right? I already explained ECR when you guys attended DevOps course. So if you guys attended DevOps course with us, right? I also explained how to create ECR, how to push images to the ECR, how to pull images to the ECR. Also, that is already done. I am not going to build any single Docker image in these sessions. I am not going to build any single Docker image. I am not going to push any Docker image. I am not going to deploy any application into the Kubernetes. I'll just explain how to create a EKS. EKS is one service. This is not a DevOps course where I can explain what is Docker, what is Kubernetes. No. So Terraform and some cloud services. Okay. You should have a background of Docker, Kubernetes, Jenkins, all those things if you really need all those things. Okay. Thank you. I'll continue tomorrow.